Okay, algebra, and we have been doing the delight of word problems. Uh-huh. Okay, we've had a few questions that have been discussed as we have just enjoyed that light-hearted banter about mathematics that occurs before the lecture starts. Are there specific questions that we still want to address? Jennifer, do you still have one that, okay, you're happy now. Okay, Perry?
I think actually it was answered.
Okay, so the two questions we'd had earlier I think are okay. Anybody else with a question regarding these problems? Beatrice? Okay, we have one, which is number?
Number 30. Two, she said.
Oh, you're Michelle's getting counted. It's 32. 32. Is that the one that you wanted to look at? Oh, 32 and 30. So we can average that and get 31?
Okay, let's do it.
Okay, starting with number 30. A small plane, okay, is going to travel 200 miles per hour. So as we look at this 30th problem, we've got a speed given, and, oh, that's with the wind, okay. And it does what, 120 against the wind? And we need to know that this problem is set up like number 29. The idea is you will travel or fly a certain distance in 1 hour. So you could argue that in 1 hour you're going 200 miles with the wind, and in 1 hour you're going 120 miles against the wind. So if I let x be the speed of the plane, y equals the speed of the air, then I would have 1 times x plus y is 200, 1 times x minus y is 120, and I'm in business. That is the same type of solution we did on number 29. Now number 32, I guess, was the next one. Do we need to write that other one on the board, or is that enough? Just with 1 times x plus y and 1 times x minus y? We okay there? Okay. Number 32, Kansas City and Denver. Now if you didn't know this piece of information, you have gained some knowledge from being in here today. That Kansas City and Denver are 600 miles apart. It will be valuable in some Trivial Pursuit game in the future. Now, you have them starting from these two cities, and they travel toward each other. They're going to meet for lunch. They meet after 6 hours. Now, one car is going 30 miles per hour slower than the other. Now, that's when the problems cease to become reality. Two cars on the freeway, one doing 30 more than the other. One of them is going to be picked up for going either too fast or too slow. And they will never meet for lunch, and so reality would have been better if one is 10 miles an hour faster than the other, or something of that nature. But let's look at the problem from the standpoint of a little bit of a diagram, and that diagram may help us understand what we're going to do here. We have two variables we're obligated to. We could do this problem with one variable. Okay? So we're going to approach it, how do you address the problem? I'm going to think in terms of just a very simple A and B kind of diagram, but I'm going to call it K and D. DK instead of KD? KC. Well, Kansas City starts with a K. You want 2 letters. Now, what 2 letters am I going to use for Denver? Okay, this is called no-win. I have 2 cars. They are going in a direction that's going to cause them trouble. But this is a distance of what? 600 miles. Now, the key here is in what we let x and y represent. I'm going to let x be the speed. And just a comment here, x cannot equal a car. X should represent a number. So this would be the speed of fast car. You could have let it be the speed of the slow car, and you don't have to use x's and y's, but it's traditional to do so. Let y equal the speed of slow car. Now, knowing those two, we know one's 30 miles an hour faster than the other, so we could just say x minus y is 30. And I have an equation. Now, when you use two variables to do word problems like this, usually one equation is really easy. One of them will be nice, and the other not as nice. Now, this one turns out both of them are pretty decent, but this is certainly the easiest. Now the question in terms of the problem. 6 hours. Okay? So 6 hours, they're both driving 6 hours. You could just put the 6 out in front, but I'll do the 6 times x plus 6 times y, and that's going to equal what? 600. Now the question, you might look at this and say, well, why don't I go up here and just multiply by 6? I could. Or I could do what here? Divide everything by 6 and then add. I could multiply by 1 over 6, and that would give me the following system, which I like. X minus y equals 30, and x plus y equals 100. So 2x is equal to 130. And so far this seems rather reasonable. X is 65. However, the other person is going to travel at what speed? 35 miles per hour. Never. They're terrified by the freeway, have never been on a freeway before, and they get on the freeway and decide they better drive slowly.
It's all flat.
Well, but there's a lot of flat land there between the two. If you've never been in the area of Kansas City driving towards Colorado, and you haven't hit the Rockies yet, you're pretty much flat land. Now, by the way, if you were driving out of Kansas City at 35, you are in deep trouble because every trucker will be on your bumper pushing you along because there's no tolerance for 35 miles per hour in Kansas City. Now, as you get closer to Denver, maybe more tolerance, and you may be lucky and get behind a tractor rig coming off of a cornfield or something, and that would slow everybody down. But the only way that makes sense here is this person got behind a trailer tractor doing maximum 35 miles per hour all the distance, and you couldn't get around them. That would make sense. But the problem is simply a matter of forcing on this problem a two-variable solution. These problems, I think, in many respects, are actually less difficult problems than we worked before. They just involve two variables. And so to that extent, not too bad. And then, of course, you might want to check your solutions here. Yes?
I did this problem like the example in the book where they had, 6x plus 6y equals 600, and then y equals
Oh, you did it by substitution.
x minus 30, so I just automatically have
Okay, you can do substitution. That would be a substitution
because it
technique.
didn't specify which way.
Yeah, or you could say x equals y plus 30, which is a little bit of my note in response to a question. There are times when you see a system that is easier to do with substitution. And I think you have that choice. I just happen to see this as the x plus y equals 100. I immediately add, get a very quick solution. The substitution is a technique which lends itself to the problem. I concur there. And I guess one of the other things, we talk about how you prepare yourself for other classes in the future. See, there's an implicit assumption there. You're going to take another math class. And then another one after that, and they just seem rolling along, and a few years from now, you're still in mathematics. But the idea here is substitution is an important concept. And if you can get comfortable with it here, it will really help later. Because in courses after the 90 sequence, when you get into what we call our 2-semester sequence before going into a calculus course, if you chose to do that, substitution tends to cause problems for people. They just aren't comfortable with it. So I would practice it just occasionally to keep my mind focused on that as an option. Changing the topic in a similar way, one of the things I tend to do as I'm looking at voicemail at 5 in the morning, 5:30, there's a Channel 13 broadcast, and once a week they have a fellow from one of the golf courses, and today he was talking about what do you do if in a golf game your golf ball lies about yay close to a big tree, and the tree he had it next to, you couldn't even get your arms around. It was one of those big oaks that you just weren't going to do anything other than you had options. And that's what he was trying to argue. You could take the ball, drop it somewhere else, lose a stroke, and then he showed a couple options of how actually to try to do something to get out of the trouble. In mathematics, there is a tendency to want things very well determined. See this problem, do it this way, and it works always. And you can do that. But there are times when having a few options gets a little more comfortable, and I'm hoping that as you do these problems, you see the options as an alternative. Rather than avoiding them, look at them as a possibility of how to simplify a solution. The downside of that argument is under stress, you tend not to consider options and you just say what works. But if you have the luxury of a little bit of thought, then you have those options. And it's the difference between being in a test environment where you just say, tell me what to do, show me the money, as opposed to you're sitting at home, cup of coffee, glass of wine, kick back, relaxed, music playing, and you're thinking of options you have in mathematics. Isn't that warm kind of thought? I mean, that environment. Yes, warm and fuzzy, just goosebumps all over. Okay. Are there other questions on the homework? Very good. I think that covers them, so if you will pass that in, and we'll now get into the artistic portion of this chapter. And it intrigues me what's done here, but we'll talk about it in a moment. This became a topic of conversation between me and one of my colleagues this morning about a text that we are considering. And the text that we were looking at just was like a manuscript. It was print on a white page. No color whatsoever. And I thought, boy, that's refreshing. Well, publishers have found that 3, 5, 35 million colors will cause people to look at a publication and be enamored with it. Lots of color, it's got to be good. So with that in mind, I'd like to show you their choice of color on a problem on page 503. Gray. Now that, of all the things we could select, and they use color to such an extreme in this book that gray just seems like, yeah. Anyway, enough said for that problem. Now, there's a little better effort to use the multiple shades of the palette. And I'm going to have to shade this book. It's the only hope. There we go. I think I've got it. Now, see if I pull away how it changes. Isn't that neat? Okay, something like music. Anyway, we have a blue, and that's supposed to be pink. And the monitor I'm looking at has some question about the pink nature. It looks orange in the back monitor. But whatever the case, we have two regions. Now that's like in two lines. So we're going to look at those two for a moment. And the particular equations involved, I'll come back to the system on page 501. So this is our system of inequalities as opposed to what? Equations. So we have a very nice two-inequality, two-variable system. And it's a linear inequality. Do you note how nice the authors were in this problem? What do you notice as you just look at that problem for a moment? Whole numbers. I know where you're
The one we're
going.
working with here.
What are you going to be trying to get that those whole numbers are so nice? Simple way to graph. Two intercept. Let y be equal to 0, get x. Then let x equal 0, get y. Let's go back to the problem. And 3 goes into 6, 2 goes into 6, 2 goes into 10, 5 goes into 10. I mean, the text is being generous to a fault. Okay? Now, if you appreciate how nice this system is, I will feel a little bit better. So you want to keep me happy, feel good about this. 2x minus 5y greater than or equal to 10. Now notice also that we have one less than or equal and the other greater than or equal. So they flip-flopped. I hope, there's an assumption here, that you remember how to graph one of those inequalities. Okay? So if you know how to graph one, you can graph the other and we're okay. And the equal symbol is supposed to tell you something. And what does it tell you?
Solid line.
The line is included, a solid line. Okay? That's what the equal symbol is telling me. If it didn't have the equal symbol, then what would I have to have? Dotted or dashed, something to indicate the line itself is not included. Okay, back to the problem for a moment, Debbie. We need to get the intercepts. Can you write your ordered pairs while you're looking at that and get the necessary form of the ordered pairs to get the intercepts? So what I'm thinking about in these two, the first one, so I'll call this line 1. I'm going to have a 0 space and then another one that's space 0 for line 1. Now the first is always x. So if x is 0, 3 times 0 is 0. I have 2y equals 6, so y equals 3. Now you don't need to worry about which intercept it is as much as that is a point you're going to plot. Here I have an ordered pair with 0 as the second member, which is saying y is equal to 0. So then 3x is equal to 6, x is 2. Now when does this technique not work? When it goes through the origin. So when your line is going through the point that the two axes meet, and I'm trying to avoid Debbie's version of the graph. Okay, but that would be the one time this doesn't work. So line 2. Okay, again, same argument. X is 0, so the 2x goes out, and I have negative 5y equals 10, so y is negative 2. We okay there? Second order pair, I want y is 0. So if y is 0, 2x equals 10, x is 5. Now if you do that much, you've got your graph because 2 points will determine that line. And it's just a matter now of graphing these two lines. And then, of course, I need to find regions. But let's graph the lines first. So I have an x and a y. And I need a scaling that's going to allow me to get what? A 5 out of this. So 1, 2, 3, 4, 5. 1, 2, 3. I'll go up to 4 there. Left side, don't need this in this case, but I'll do it. And then down here, we have our divisions. Now my first ordered pair was 0, 3. I'm going to go ahead and just indicate the ordered pair there. And related to that was another ordered pair, 2, 0. And I want to join those 2 points. That is line 1. Because of the equal sign, I need it to be solid. Now, at this point, let's go back to the system just for a moment. The system on that first line says I want what? A less than or equal. So I need a test point. So let's just isolate in that first line. 0, 0, when possible, the test point. So test 0, 0. Does that ordered pair, which is the origin, satisfy the first inequality? If I put 0 for x, 0 for y, I have 3 times 0. 2 times 0, that's going to give me 0 plus 0, which is 0. That's less than 6. So I'm in business. So I'm going to just lightly shade in the region because the diagram will be less complicated doing that right at that point. Now, my second line, if we can go back just for a moment, I have 0 minus 2 and 5, 0. I think I'll call this L1 up here. So 0 minus 2, so that's this point down here. And I'm going to call that 0 minus 2 right here. And then 5, 0, this was 2, 3, 4, 5 zeros out here. And I'm going to join those two. Solid line again. Now again, my question is what? What test point? Can I use 0, 0 again? 0, 0 is not on the line, so 0, 0 is going to work. Let's go back to our system. 2 times 0 minus 5 times 0, that's 0. Is 0 larger than or to the right of 10? The answer is no. So this region up here is out, and I'm with a region down here, which I'm going to first do a little better job of extending my original problem. And now I'm going to use gray, white chalk on here. This is the other region I want. Now what you're supposed to see is a region where I have both the white and light green shading. And so it's this region right in here that is just flowing out forever. And that is my simultaneous solution for my system of linear inequalities. Because it had to satisfy what? This line I'm showing with my arm, it had to go this way, and then in this one it had to drop down this way, and at the same time it's only this region right in here that's defined by, and I'll try to make this a little bit larger here, and this coming over. Now we don't usually think of lines being quite that wide, but that's the wedge that's involved. Any question in that? System of inequalities. Here's your original system. Here is our solution for it, and that would be your problem. Now, in a situation like this, if you have, say, 2 different colored leads, maybe a blue and red or something like that, or crayons would work very nicely. The highlighters work pretty well, except you put that much ink on it, and it pretty much, the paper gets soggy, and so, but somehow you have to indicate to me the solution. Any question in that one? Yes?
Is there anything further that we need to do after we graph?
That's it.
That's it. And just put, what would be the solution, the simultaneous solution?
Well, you might do something like this. Region of simultaneous solution. Something like that. That's about all you can say. It is a region. It's an infinite number of points. Pretty clear at that. Anything else there? Okay. We need to look at another one. Let's try 3 things at once. Oh, I think that's a good idea. Let's go to 26 on page 505. There we go. Now, let's see what you can do with this one. I'd like you to set it up, and Debbie, what we're going to do is sort of zoom out on that a little bit so people can have an opportunity to try their hand at it, and then I will do a little bit of just observation, and then we will talk about the problem. And I think it's fairly clear that at some point we're going to have to, and I'll make sure we make the transition, but I'll pack up some of my tools, my chalk, and we'll get over on the side here in a moment. Now again, the key is start your problem by going ahead and graphing each line. That's the key. And we'll see what we can do over there on the side pretty soon. Well, let's see what you can get as you work with that. And straight edges really help at this point. Use those credit cards at a low interest rate. No charge for making straight lines with them. Okay, let's see how we're doing. Okay, we need only one set of intercepts because the other one's pretty easily done for you. If you remember what we did with inequalities. And the start is, if nothing else, draw a coordinate system. A coordinate system would be a good place to start the problem. Okay. So we'll just wait for some coordinate systems. See, the great pun here is we are coordinating our effort. Okay, this is always the time-consuming part, getting that coordinate system drawn. But I think it's very important for you to have an opportunity to draw the axes, show the regions, plot the points. Okay. So what I will do now is the same thing I'm asking you to do. So we'll go to the sideboard here. Oh, I need to have you with an opportunity. Let's go back to the dot cam for a moment. That is, and I need that in fact, so let me write that. Less than or equal to negative x plus 5, and y greater than or equal to 2, x greater than or equal to 1. This is number 26. Okay, and I'm going to then draw the coordinate system again. And we've got that done. Now there's a question as we look at x, we look at y, and I'm going to run a scale here that's pretty arbitrary, I realize. It's just the idea of keeping the same scale, vertical and horizontal. And I have one more to do. Now, in terms of what I've done there, as we look at that now, we are going to go ahead and plot 2 easy lines. So if we can come to the equation here, these 2 lines, what's the first one here? Y greater than or equal to 2 is a line. What line is it? Can you remember that one? If y is a constant, it is what kind of line?
Horizontal.
Okay, I've heard vertical and horizontal.
Horizontal.
Y stays the same all the time, very level, so it is horizontal. So that says y equals 2. Now, y is always the same value, so that would have to be a horizontal line. So I'm just going to call that y equals 2. Now, what might I want to do here? Find the region immediately. Y greater than or equal to 2. What does it say? Above the line. Agreed? Above the line. Okay, I changed some colors here. I'm always concerned how these show up on the camera. Sometimes they don't look a whole lot different than what I'm doing with just the chalk, the white chalk. But that's my first one. What about x equals 1? What line? Vertical line at 1. Okay, so a vertical line at 1. Notice it's a solid line. Why? The equal sign. Agreed? Okay. And I want x greater than that, which means to the right. Agreed? So let's try some blue lines or blue shading here. Is that coming across okay? Looks pretty fair. Now so far I have what? A little region up here. Now what's my next problem? To graph the line that is not a horizontal, not a vertical. So for that we needed what? Some OPs. Do they still do OP, Ocean Pacific? For where? See, the next time you see OP, you'll think ordered pair. Bad. Sure you will. Okay, we want the 2-intercept result here. This is for line 3 now. So I want the 2-intercept approach, and again, all you have to do is create these 2 ordered pairs. That looks like x at 0 for the first, tells you y is what? 5. I'm going to talk about this problem in a different way in a moment. And if y is 0, x is 5. Now you can do it as 2 intercepts. What else could you do? What is the form it's given? If I just told you I have y equals -1 times x plus 5, what form would you say I have given you?
Slope-intercept.
The SI form. Slope-intercept. Right? So what is the intercept? The constant. That's at 5, and there's my 0, 5. That is the intercept. And what's the slope? -1 over 1 is understood. So that says if you go over 1, then you go down 1. So I know that I'm going to be at 5. Now I have 1, 2, 3, 4, 5. I need to extend that line upward so we can see the intercept. This is the intercept up here. And I'm going to do what? Also have an intercept down here. This was 1, 2, 3, 4, 5. So I need to extend this line out. So here is the other intercept. Okay. Well, I thought this was 0. This was at 1. So remember, this was x equals 1 right here. This was y equals 2 right here. So this is actually my origin here. So it looks like it's 4 from there, but it is starting from the origin. Now, I'm going to go ahead and join these 2 points. This is my line y equals minus x plus 5. Now I want the solid line here also. Now before I leave that, note, if I go over here 1, I have dropped down 1. So if I started at my intercept and used the slope over 1, down 1, I actually get to that second point. Now the question, what side do I want to be on? Well, does 0, 0 as this test point work? So let's go back to the system. Is 0 less than or equal to 0 plus 5? Yes. So this region right here works. Okay. Hoping this shows with 3 different shadings going on. And of course it comes down here, continues up here. Now, what region is covered with all 3 shades. I have a little triangle right here. Now let me try to increase the size of that in terms of the border. There's the diagonal part. Here's the leg. In fact, it's a right triangle. Debbie, I'm going to have you just zero in on that because that may work better if we do that a little bit tighter even yet. And maybe you can see the different shades. Not as, okay, if I point with the meter stick, up here is your pink, or sort of that's a shade of pink. And that was going above this line. So if you look at the shading above the line, that's where you have those pink bands. Then to the right of x equals 1, okay, that's where I have these blues. Then below y equals minus x plus 5, I have these white shadings going. And all three of them are in that little triangle now. Those are covered with pink, blue, and white. Red, white, and blue. That made a patriotic problem for today. Okay, that's a triangle, and that's the region. Okay, sort of nice. Let's go back to the document cam for a moment. That's the solution for that one. Is there a question about what we did there? Any discussion on that? Okay, this is, I feel like speak no evil, hear no evil, and see no evil. I'll just be real quiet. Maybe we won't have to do these. That doesn't work, right? Let's see if we can find something a little interesting, a little more provocative, well-seasoned. Oh, yes. I'm looking at 23. Warm, fuzzy, feely time. Okay, here we go. 4 of them. We had fun with 3. Think of the delight with 4. Okay, I'll let you work for him. We'll leave that on the screen for just a moment, and then we'll zoom out and see what's going to happen as you try this. Now note, you have what? A horizontal line, a vertical line, 2 diagonals, one greater than or equal, the other less than or equal, and all of them have an equal sign, so all of them are solid lines. This should be fun. If you have no idea what in the world to do, draw what first? The coordinate system, the XY axis. That and, of course, writing down the problem. Both are good time fillers. If you draw the coordinate system and write down the problem, you at least know that you're going to be doing productive work. Okay, let me check over on the other side and see what we have happening there. Now remember, your horizontal line and your vertical line should go pretty easy. That should be pretty fast for you. A floppy disk works as a straight edge. I hadn't thought of that. That's a neat floppy disk. Where can I get one of those?
It's old.
Oh, that's neat. I've got to borrow that for a minute. This is the neatest floppy disk I think I've ever seen. I like this floppy disk. There we go.
Oh.
That's neat. Boy, I mean, if I had that floppy disk, I could really feel good.
You like to have some?
That's neat. I like that. I didn't ever think of a floppy disk as a straight edge. Very good idea. Okay. I know. Those CDs aren't, I mean, just don't make good straight edges. See, that's where technology is working against us. We're replacing the floppy with the CD, and you can't draw straight edges. put the CD in a case. Okay, a jewel case, and then you have a straight edge. Okay, I stand corrected. Okay, now one of the things I'm going to ask you to make an effort at doing, draw coordinate systems faster. You're taking it too long. Okay, we are getting the coordinate system drawn, and now we're going to plot points. We're making progress. We even have some shaded regions. Okay, we're making excellent progress. This is going well. You're becoming pros. That keeps in my concept of a golf ball and a golf range. And okay. Debbie, could you go back to the document cam so I can write that system, please? Thank you. 23. So we have 3x minus 2y greater than or equal to 6. I have x plus y less than or equal to 4. I have x greater than or equal to 0. I have y greater than or equal to minus 4. Okay, that's a neat looking mess. Coordinate time. Let's see what we can do. So we have our x-axis, we have our y-axis. We need a scale, so I'm just going to do my usual. Now usually I find that I run about 3 units on each axis, and then I can extend it if I need once I'm working with the problem. Now the 2 easy ones, what are they? There's 2 parts here that are easy. The x greater than or equal to 0 and the y greater than or equal to minus 4. Okay, let's start with the y equals minus 4. What kind of line? Horizontal, right? And it's a negative 4 I want there. So I'm going to go down one more space and run this line. Now this is where I've got to make it look parallel. Is that looking about parallel? I think it still looks uphill. Anybody else? Which way goes? You're saying down a little bit here? That better? Okay, thank you. Now I want what? The y values that are what as we look at our system? We say y greater than or equal to minus 4, so we're above it. So that means I have this, and my guess is I don't have those red or pink shadings far enough. But what about the other easy one? Greater than or equal to 0. This is just your vertical axis at x equals 0. And I want to be to the right of that, correct? So, I'll do it this way. Now we can see already that we have some intersection. And I need to drop this vertical axis just a little bit. And it might help to keep things straight that this is x and this is y. That would have helped in the last problem when we got a little bit of confusion with which line was the axis. Now that's the easy part. Back to my system. Do you see how much this is delightful? X plus y equals 4. X is 0, y is 4, y is 0, x is 4. So I'm going to have a 0, 4, and a 4, 0. So 1, 2, 3, 4. Here's my 4, 0 point. And 0, 4, I need one more up here. Okay, so that's going to be this region. And now, what's my test point? 0, 0, did it work? Yes, I need more chalk. Okay, let me walk off camera for a moment and get a couple more colors. We'll try green and not very good selection here. I've got green and something that may or may not work, so we'll try green at least in this case. 0, 0 worked. So I'm going to come back here now and take this region from here down because 0, 0 worked. Okay, so I'm going to do this. Oh, we're getting some interest. Boy, those just don't come across with what I'm seeing up close to. Maybe when we shortly do what we want. So far I have what? A region that looks like a very big triangle. I need to bring this line down further. But we have yet a what? Another line. Okay, back up to here. Now do you see again how nice the problem's been set up for you? If x is 0, y is minus 3. So we have 0, minus 3, 0, minus 3, 1, 2, 3. That's this point. And then if y is 0, x is 2. So I'm over here at 2. And I have yet another line. Now, I'm going to leave the straight edge there for a moment. Let's do our test point. 0, 0. 0, 0 is on this side of the line, above the straight edge. Does 0, 0 work as a test point? 0 minus 0, is it larger than 6? No, so I want to be on this side. Do you follow me? Okay, so I want this side. And I'm starting to see a region that has what? All three shadings. Now let's see if we can pick up on that. Okay, I see green, red, blue, and white right in here. And it goes only to where? Down this far. Boy, what can I do to make that? Okay, let's see if I can darken that a little bit. When I try to erase the board today, I will pay for this. Now I'm going to be above that straight edge. I'm going to be where? Below this line. So I have this region up to here. But I have to be where? To the right of here. Is that correct? I had to be to the right of the vertical axis. So I have that. This line needs to come down and meet. Now I had to be what? Below this line. So it looks like, okay. This is a heck of a thing to do to a line. Okay, I want to come to here. Feel like I'm doing an edge on a doily or something. My aunt in Iowa would be proud. Okay, and then here. Now, does that help? So this is not a triangular region. This is a region that has 1, 2, 3, 4 sides. Okay? And a little bit difficult to see on the board as much as I'd like, even with the close-up. The green lines, the pink lines, the blue lines, and then the white shading just sort of gets lost in there. And I don't know that we can do anything better on that. Any suggestions, Debbie? Get better chalk. I know that's the... If I get chalk that does any brighter, it's impossible to erase from the board. Just sort of sinks in. Get the idea? Now that's the worst it gets. So let's go back to our document cam to see what fun we've been having. That was the problem we did. Now let's go back to where life was simpler. No. You want to start over? Is that what I'm hearing you say? Just review everything. Okay, let's see. Just a minute, Debbie. I'm still not getting nice, clean focus. There, let's try that. Now this is probably as easy as they get. Number 5, will you try this one as we finish up here? X plus y less than or equal to 6, x minus y greater than or equal to 1. So that's our system. Okay, Debbie, if you want to just do the camera out, and I'll try to get this so we can come back to it here in a moment if we need to. And people are just going to again draw the coordinate system. If there's nothing else you've gained out of today's lecture, it is learning to do a lot of coordinate systems. So let's see how fast we can go with this. We only have about 2.5 minutes, 3 minutes max. We get to do this one. And the 2-intercept form in this one is really fast for you. So we've got our coordinate system. We just plot 4 points, get the regions, and we're home free. And remember, you don't need to have like 15 hash marks for your coordinate system. 3 or 4 is all you need. So don't get carried away with that and go out to 23. Yeah, but just try to keep it minimal. Minimize now. Save chalk, save lead, save ink. Be environmentalist. And if you really want to be an environmentalist, you wouldn't be wasting the paper doing this, right? So, okay. Okay, you're down to about a half minute to get the next line done. We're making progress here. Going faster. This is good to see. A little bit of pressure. I'm going to get you a little egg timer. All problems have to be done within 1 flip of the egg timer. Okay, let's go to the document cam for a moment. This is number 5. So we had x plus y less than or equal to 6, x minus y greater than or equal 1. Don't you wish you were just doing a system of equations? You just add those two and say 2x equals 7 and you'd be there. You didn't see that as an advantage, I can tell. No interest whatsoever. Okay, as I said, let's try to keep this fast. So we have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3. And now, the first one. If x is 0, y is 6. That's up here. I believe 1, 2, 3, 4, 5, 6. And if y is 0, x is 6. 1, 2, 3, 4, 5, 6. Here's that point. Simply join them. And is the origin the right region? Yes. So I want this region immediately. Now my second equation. It was nicer because if x is 0, y is 1, and nope, negative 1. I just caught the sign on that. Sorry. And if y is 0, x is 1. So this is my next one. And now the question. Is the origin satisfying? Is 0 plus 0 greater than 1? No. So I have to be what? Below. So that one is going to be like this. And you can see the region that's joined right here. So it's this region where I have cross-hatching going, and we include the lines. That's the idea. That was a little bit faster, I hope. Agreed? So let's go back to the problem in the book. That was one of the easier ones. We've done a couple of the harder ones. And so as we look at these, we will start with number 1. We will go through number 28, and we will do odds. 1 through 28 odd. We've done a couple of them. That's on page 504 and 505. Debbie, as we close down, Blues Brothers and...
Brothers, since we started with traveling, I picked home Chicago.
Yeah, that's got numbers in it. Sweet Home Chicago. Have a great day.